Hello everyone and welcome to Keeru's online lectures. I am Keeru and today's topic is Hydrocarbons Part 1. So in this chapter we have to study about hydrocarbons, what is hydrocarbons, the introduction of it, then alkanes, alkenes and alkynes. In part 1 we are going to study hydrocarbons and the introduction of hydrocarbons and about alkenes. Coming on to the introduction part. So basically what are hydrocarbons? They are the compounds of carbon and hydrogen. We call it as hydrocarbons. Important fuels like petrol, kerosene, coal gas, CNG, LPG, these are all hydrocarbons or their mixtures. Now from where these hydrocarbons comes, that is the sources. Petroleum and natural gas are major sources of aliphatic hydrocarbons, while coal is an important source of aromatic hydrocarbon. The oil that is trapped inside the rocks is called petroleum. Petra means rock, oleum means oil. So oil in the petroleum field is covered with a gaseous mixture and that is known as natural gas. The main constituent of this natural gas are methane, ethane, propane, butane. They belong to alkane series. Coming on to the classification of hydrocarbons. So these hydrocarbons are classified in two categories. The one is aliphatic hydrocarbons, or we can call it as acyclic hydrocarbons, that is open chain hydrocarbons. Next classification, the second type is cyclic hydrocarbons. Now in acyclic, or we can say aliphatic, we have three categories. The one is alkanes, alkenes, alkynes. So in this chapter we basically have to study about alkanes, alkenes, alkynes and aromatic compound, that is we have to study about the benzene. In cyclic there are two types. The one is alicyclic and the other one is aromatic. Under alicyclic we have cycloalkanes, cycloalkenes and cycloalkynes, and under aromatic we have benzene. So in this chapter we basically have to study about alkanes, alkenes, alkynes and benzene compounds. So starting with the alkanes. Alkanes are, the general formula for this alkane is CnH2n plus 2. So these are called as paraffins. General formula as already discussed, it is CnH2n plus 2. Since over here these are bonded by single bond, so there are 4 sigma bonds. If 4 sigma bonds are there, so it is sp3 hybridized. The CC bond length is 1.154 angstrom. They are chemically unreactive. Why they are chemically unreactive? Because all 4 bonds are satisfied by a single bond only. Now they show chain, position and optical isomers. Heptane, it has 9 isomers, octane 18, decane 17 isomers. Coming on to the nomenclature, like we have general formula CnH2n plus 2. So if we will take N1, for N as 1 the prefix is meth and suffix is ane, so it will be methane. So substituting N as 1 over here, we will get CH4. Similarly N as 2, the suffix eth and the prefix eth and suffix will be ane, so the name becomes ethane. Now C2, substituting 2 in place of N, so we will get C2H6. So the structure of C2H6 is CH3, CH3. Similarly N as 3, is propane. So its structure is CH3 CH2 CH3. Similarly, N4 is butane. So its structure is CH3 CH2 CH2 CH3. Coming on to how to prepare alkenes. So the first reaction for preparing alkenes is from unsaturated hydrocarbons. Unsaturated hydrocarbons are alkenes or alkynes. So like, let's suppose I am taking alkene over here, RCH double bond CH2. So on alkenes, on hydrogenation, hydrogenation is addition of hydrogen in presence of nickel, will get RCH2 CH3. That is, these two hydrogens are there, one will go to this carbon and other will go to this carbon. Similarly, if we have triple bond, so R C triple bond CH plus H2, again the catalyst nickel will take, the same product will be formed. So this is first method of preparation from unsaturated hydrocarbons, and this reaction is known as Sabatier-Sanders reaction. So the first preparation is from unsaturated hydrocarbons. Second is from alkyl halides. From alkyl halides, the first which we prepare over here, the first reaction is Wood's reaction. In Wood's reaction, we take alkyl halide like CH3Cl plus sodium in presence of sodium. Here 2 moles of alkyl halides are taken, so we will write like this. Thus, this NaCl will be eliminated. This reaction takes place in presence of dry ether, and we get ethane as a byproduct. This reaction mainly follows free radical mechanism, and yes, we are taking 2 moles of the carbon of the reactant, therefore even number of carbons are prepared by this reaction, and this reaction comes under the category of a stepping up reaction. Why we call it stepping up reaction? Because if we take 1 carbon, we will get 2 carbon product. If we get 2 carbon, like I am taking over here ethyl chloride, so same 2 moles of ethyl chloride we have to take. Again this will be removed. Thus we took ethyl chloride and the product formed will be butane. So therefore this reaction is called as stepping up reaction. The second is reduction of alkyl halide. We will take over here CH3Cl plus zinc. With the help of zinc only will reduce. So this zinc will perform reduction with HCl. So thus we will get over here methane of the same carbon. This Wood's reaction, in Wood's reaction, if we are taking 1 carbon of alkyl halide, so 2 carbons of alkane will be prepared. But in reduction, the same number of carbon will be prepared in the product. The third is from carboxylic acids. So in carboxylic acid, again we have 2 methods. The one is decarboxylation. In decarboxylation, we take sodium acetate CH3COONe and along with soda lime in the ratio of 3:1 ratio, we will take NaOH and CaO. Soda lime is basically NaOH and CaO in the ratio of 3:1. From here Na2CO3 will be removed, thus we will get CH4. So in this reaction we can see, in reactant we took 2 carbon of acetate, but in product we got 1 carbon of alkyl and 1 carbon of alkane. So this reaction is stepping down reaction, that is the product will always be 1 carbon less than the reactant. For example, if question comes, we have to prepare over here ethane. So if we have to prepare ethane, which acetate will take? So the acetate will be taken as sodium propanoate, because one carbon less product will get. So, sodium propanoate if we will take, then only we can get ethane. The second reaction from carboxylic acid is coal base electrolysis. Now, in this coal base electrolysis, what we do, we will take sodium acetate, but the 2 moles of sodium acetate is taken, CH3COONA, CH3COONA. In this reaction also even number of alkanes are prepared, and plus, because we are doing over here hydrolysis, HOH, HOH. So, this NaOH is removed, CO2 and CO2 will be removed, H2 will be removed. So, on electrolysis we will get over here CH3, CH3, that is ethane, plus CO2 plus H2 plus NaOH. So, this is how we completed the preparation of alkanes. The first preparation was from unsaturated, second was from alkyl halide, and third from carboxylic acid. Coming on to the physical properties of alkanes, the physical properties, nature. Alkanes are non-polar in nature. Why they are non-polar? Due to covalent nature of C-C bond and CH bond. Solubility, as we know, like dissolves like. So, polar compounds dissolve in polar solvents and non-polar compounds dissolve in non-polar solvents. So, as we know, alkanes are non-polar, so they will dissolve in non-polar solvents. Like dissolves like. Boiling point and melting point. So, boiling point, it is directly proportional to the molecular mass, and boiling point is directly proportional to surface area. So, as we can see over here, if we have like ethane, butane and pentane, so pentane will have highest boiling point, then butane and then propane. This is according to the molecular mass. Now, if we have neopentane, isopentane and normal pentane, so surface area of normal pentane is highest, then isopentane and then neopentane. So, more the surface area, more the boiling point. Next, coming on to density. So, density, it is also directly proportional to the molecular mass. So, as we can see, pentane, it has highest molecular mass, so its density will be higher as compared to butane and propane. Now, coming on to chemical properties of alkanes. So, the very first chemical property of alkane is halogenation. As we know, alkanes are unreactive, all 4 bonds are single bonded only. So, alkanes show substitution reaction. So, like we have CH4 will perform halogenation, will take halogen in presence of UV rays. So, this H and Cl, H is replaced by Cl. So, we will get CH3Cl plus HCl. If further halogenation is performed, we will get CH2Cl2. If further halogenation is performed, we will again get CHCl3, and on again halogenation we will get CCl4. So, this is how halogenation is performed for alkanes. Now, this halogenation, if we talk about the reactivity of halogens over here, so fluorine is more reactive, then chlorine, then bromine and then iodine. The rate of replacement of hydrogen, so tertiary में सबसे ज़्यादा replacement, then secondary and then primary. Now, this reaction basically follows free radical mechanism. Coming on to next, that is combustion reaction. Now, combustion is basically we will take alkanes and will burn them in presence of oxygen. So, whatever alkane we will take, either it may be methane, ethane, propane, every time the product will be CO2 plus H2 plus energy is released. Coming on to next, that is controlled oxidation. This controlled oxidation means we will be taking agents over here, like we are taking CH4 plus O2 in presence of copper if it is written. This is controlled oxidation. So, if we are writing copper over here, we will get alcohol, that is CH3OH. In same reaction, if we are taking molybdenum oxide, the reactants are same. Now we will get HCHO, that is aldehyde. Again the same reactant, but the oxidizing agent is manganese acetate. So, here the product will be acid, which is HCOOH. Next is reaction with steam. So, now if we have alkane over here, CH4 is alkane, this is reacted with a steam. So, in steam what happens? This reaction and this reactants will form CO plus H2, and this CO plus H2 is hydrogen gas. Coming on to next, that is pyrolysis reaction. Now, what is pyrolysis? Pyro means heat, lysis means breaking. Let us suppose I have taken over here hexane, CH3, CH2 whole 4, CH3. Now, at high temperature we have heated it. So, this hexane will convert it into its smaller constituent, that is it can form butane plus ethane. So, this is known as pyrolysis. Next is isomerization. Now, what is isomerization? Isomerization is basically the formation of isomers. So, let us suppose if I am taking over here hexane, again CH3, CH2 whole 4, CH3, and this isomerism takes place in presence of anhydrous aluminum chloride with HCl. So, the isomers of this hexane will be formed, that is it will be 2-methyl pentane, or it can be 3-methyl pentane. So, this is all about the chemical properties. One more property is there, that is aromatization. Now, aromatization says the formation of aromatic compounds. Now, as we know, the aromatic compound starts from 6 carbon. So, here we will take hexane. Hexane in presence of chromium and vanadium oxide Cr2O3 or V2O5 at 773 Kelvin, 10 to 20 atm pressure. Now, since that is 6 carbon alkane, so we will get over here benzene. If let us suppose in question we are provided with heptane and all these same conditions are given, so in that case the product comes out to be toluene, because we know aromatization means the formation of aromatic compounds. With 6 carbons we will get benzene, but if we have 7 carbons we will get toluene. So, in today's video we studied about alkanes, what are alkanes, how to prepare alkanes and its physical and chemical properties. Hope you guys are finding videos helpful. So, do like, share and subscribe the channel. Thank you.